Well, my dear participants, hello. Well, my dear participants, today I am going to continue with dplyr, and we have already opened a PDF. So PDF we have. So we were having diamonds data we have already discussed. So with diamonds we are having group by cut. So it will make grouping by cut and then ungroup. So ungroup will make it just as the original observations, that is 53,940. Then count by origin. By origin is equal to flights. Then we are making the pipe. Then group by origin and then summarize. And group by origin, origin has three levels, that is EWR, John F. Kennedy and LaGuardia airports. So these are the three airports. So it returns 3 by 2 matrix of origin. This is a tip bill because here character and integer is being shown. So it is origin versus count. Grouping by more than one variable, by origin monthly. So here monthly, by origin monthly flights, and then we are using the pipe, group by origin and months, and then summarize counts. So it will have 36 by 3, and we have already talked about these things. Now mutate existing variable, mutate. You know, mutate means, the term mutant has been very common during the COVID days. People were telling that some mutant gene has come and it is more damaging. So actually in genetics term mutant is very common, but here the term is taken from the same. What we are doing, we are defining a new variable, that is a mutant of temperature. That is, here temperature is in Fahrenheit, whereas here we are going to define temperature in degree centigrade. So mutate temperature in degree centigrade is equal to temperature in Fahrenheit minus 32 divided by 1.8. So this is the formula of how to transform temperature in Fahrenheit to temperature in degree centigrade. View weather. See what will happen, that in weather, because we are having weather here and we are weather here also. So this is the weather which is the original object, and this weather is the new object. So new object contains this temperature in degree centigrade. So we can view, and certainly I will show you how we can view summary of monthly temperatures. So summary underscore monthly temp is equal to weather, then group by months, then summarize mean temperature in Fahrenheit is equal to mean temp na.rm is equal to true, and mean temp in degree centigrade is equal to temp in degree centigrade na dot, because temp in degree centigrade has been created by mutate. So it will give the summary of temperature in degree centigrade also, na.rm is equal to true, and this is the 12 months, and this is the mean temperature in Fahrenheit of temp, and this is the mean temperature in degree centigrade, and this is the temp. Get again using mutate. Again, flights is equal to flights. See, gain variable is being defined and it is a part of, see here we are taking the variables from here, that is mutate gain is equal to departure delay minus arrival delay. So this is known as gain. So this new variable has been defined and it will be added into the flights. So get summary of gains, get summary flights, then pipe, then summarize min is equal to minimum of gain na dot rm is equal to true. Then first quartile of minimum, first quartile of gain new variable which is being defined here. This is 0.525 means the first quartile na dot rm is equal to true. So it will remove nas and then it will compute this Q1. This is the Q1 first quartile. Then is similarly for second quartile or median, quantile gain 0.5, either prob is equal to 0.5, na dot rm is equal to true. Then Q3 is nothing but the quantile gain 0.75, prob is equal to 0.75, na dot rm is equal to true. So max is equal to max gain na dot rm is equal to true. Mean gain na dot rm is equal to true. SD is equal to SD gain na dot rm is equal to true. And then missing, number of missing observations, sum is dot na. I will explain what is the meaning of is dot na gain. See, and then we are getting the summary. So first I would like to go into the base and then I will talk about these things. See, mutate variable. So first require control 2, require our library, require dplyr, then require NYC flights, New York flights 13. So we are NYC flights. Oh, there is mistake in require. Here either you say require or we can say library. Both are one and same. NYC flights 13. So this is the data object. And data flights help data flights. First I will load the data flights. And then help flights. See here, flights is in the package New York flights 13. Flights data, description, on time data for all flights that departed New York, John F. Kennedy Airport, LaGuardia Airport and EWR Airport in 2013. Usage flights, data frame with columns, year, month, day, date of departure, and then departure, arrival time, actual departure and arrival times, then scheduled departure time, scheduled arrival time, then it is scheduled arrival time and scheduled departure and arrival times, and then departure delay, arrival delay, departure delay and arrival delays in minutes, negative times, respectively, early departures oblique early arrivals. If there is some negative values, that means it is early arrival or early departure. Carrier, the two-letter carrier abbreviation, C air flights to get the names. Then flights, flight number, then tail number, plane tail number. See, planes is an object, is a data frame in the same New York flights package. for additional metadata. Origin and destination, it is in airports, it is in the airports package, airport data set. Arrival time, amount of time is spent in the air in minutes, that is known as arrival time. Distance, distance between the airports in miles, hour, minute, the time schedule, departure broken into hour and minutes, time hour, scheduled date and hour for the flights as POSIT X date along with origin can be used to join flights data weather source. So this is the source. So this way we can view flights. We can view flights, FLIGHTS. So this is the data. This is the data. It has 33,36,776 rows and 19 columns. So these are the columns. This is the year, this is the month, this is the day, this is the departure time, arrival time, scheduled departure time, then departure delay, arrival delay, etc. So there are 19 variables like this. Then see what we are going to do. We have already done these things. See, we have already done these things. There are 36 such combinations. And then mutate existing variable. Mutate existing variable. So convert Fahrenheit in degree centigrade. It is weather is equal to, see, it is writing mutate temperature in degree centigrade. So temp is already there. If we view Control 2, view flights, because we are giving the weather. So view weather, and we can have the column of besides temperature in degree centigrade. This column must be added. So if we look into here, temperature in degree centigrade. So this has been added in the time hour. See, the old variable is temp. That is temp. This is the temperature. And from this temperature, Fahrenheit temperature, we are converting this into the degree centigrade temperature by using this formula. So, and we are adding this temperature into the weather object. So that's why it is coming in the end and it is being added time in degree centigrade. So this way we can add a column by making use of transformation. And then we are summary monthly temperature. See, summary monthly temperature weather. From weather we are first make the grouping by month and then summarize mean temperature in Fahrenheit. So mean temp Na.rm is equal to true, and mean temperature in degree centigrade Na.rm is equal to true, and then we can make use of the summary. So here summary temperature, summary this is the summary. There are 12 rows because we have already summarized by month. We have already summarized by months. see here, because we have already grouped by month, so that's why it is grouped by month summary. So there are 12 rows, and this is the mean of the mean temperature in Fahrenheit, and this is the mean temperature in degree centigrade of January, February, March, April up to 12. So we can have view so this is the whole data. This is the whole data which we can have by making use of the view. Now, what we are going to do, that we are going to define gain variable, gain using mutate. So flights, here this is the flight. So here we are making some manipulation, some transformation, and that transformation is that from the flights we are taking departure delay minus arrival delay, and that we define as gain. So flights gain. So gain might have been entered into the data. If we look into flights, it might have added a column of gain in the end. See, gain has been added here. Here, this is -9. So either early flight or early arrival. So this is minus. See, here also minus, but here it is positive. So here late by 17 minutes, late by 17 minutes. This is early by 24 minutes arrival. So this way we are having the gain. So gain has been added because of gain is equal to departure delay minus arrival delay. So we will close this. Now we are getting summary of the gain. So new variable we have defined. Now we want to get summary of the gain. So gain summary is equal to flights summarize. For getting summary, the function is summarize, and then minimum. Minimum is min gain. It is minimum of the gain, but provided na.rm, all the na's values must be removed first, and then it will compute the minimum gain. And then Q1 the first quantile gain, here prob is equal to 0.25, na.rm is equal to true. We know that quantile is nothing, first quartile is nothing but 25th percentile. So we are computing first quartile means 25th percentile, na.rm is equal to true. Median is equal to quantile. So this is nothing but 50th percentile. So prob is equal to 0.5, na.rm is equal to true. And then Q3, it is computing the third quartile, because here prob is equal to 0.75, na.rm is equal to true. So similarly, we can get maximum. So max of gain, na.rm is equal to true, and then mean gain, na.rm is equal to true, SD gain, SD of gains, and then missing values. So when we run these commands, we are having gain summary gain. So this is the minimum -196, then Q1 first quartile, then median, then third quartile of gain, it is 17, maximum, then mean, then SD, then number of missing. So how many observations are missing? 9,430 observations are missing. So, actually it is dot na gain. Actually is dot na, I would like to explain is dot na. Suppose x is equal to c 2 comma 1 comma na comma 3 comma 5 comma na. So, is dot na, is dot na, is there any na, is there any missing values of x? See what it is returning, is dot na 2, it is not missing, so it is returning false. Second, is dot na is not missing, so it is returning false. Na, it is missing, so it is returning 2. So, similarly, the third one is not missing, so that is why it is returning false. Fifth one is not missing, so it is returning false. But the last one is Na, it is missing, so that is why it is returning Na. And we want sum, because it is a logical vector. So, when we convert this into a numeric vector, false becomes 0 and true becomes 1. So, sum is dot na is nothing but the number of trues, the number of missing values, that is 2. So, we can have only 2 missing values, this one, and here it is true. So, this way we can count. So, similarly, the same function here, sum is dot na gain. So, how many values are missing? We have already seen that 9,430 values are missing. So, this is the summary gain, and we can view gain underscore summary. This is the object. So, it is this object: minimum, Q1, median, Q3, maximum, mean, SD, and number of missing. So, this is this object which is being created. Now, get some new variables. Flights is equal to flights, mutate, gain is equal to departure delay minus arrival delay. Then hours, air time divided by 60, air time is in minutes. So, if we divide that by 60, it will be converted into hours. So, we are defining hours, a new column of hours, because air time is in minutes. Gain per hour, it is gain divided by hour. So, it will be gain per hour. So, this way, if we, so here the two variables have been created. The first is hours and the second is gain per hour. So, we can view flights. So, here we are having hours. See, this new column, hours has been added and gain per hour has been added. So, this new variable, because of mutate, is being added in the data flights. Then get a histogram of the gain. Now, these were the numeric summaries. Now, we can have graphics. Graphics are very important from the viewpoint that it gives the shape of the data. It gives the frequency distribution. Histogram means frequency distribution of the data. So, it gives the whole picture, because a histogram contains minimum, then maximum, and then it talks about the range, then what are the maximum values, what are the maximum possible values, that is a kind of, and what are the centrality parameters. So it gives about the range as well as the shape, whether it is symmetric or unsymmetric. So here ggplot data is equal to flights, because the gain is in flights. Mapping is equal to AES, on x-axis it is gain, plus GOM histogram, color is equal to white, and bin is equal to 20. Bin is equal to 20. So when we run this, we have to ggplot2, could not find the function ggplot2. So we have to require our library ggplot2. Now it will run. See, this is the distribution. It is somewhat left skewed. So this is the gain 0. So most of the observations are around 0. So it is neither maximum flights are on time, and that's why it is 0. And there is equally, because it is right and left, they are almost equal. So they are the gain and loss, both are same. So this is the graphics. If we want to add the density, we can add density also, but I am not going to talk about density. Now, so this is the shape of the, because it gives the shape, of the distribution. Now arrange and sort rows. So here one function, say x is equal to c, say 2 comma 1 comma 4 comma 8 comma 3. If we give sort of x, it will sort in ascending order. But if we want in descending order this kind of sorting, we have to give rev and sort. So it gives reverse order, rev and sort. So here, how to make this, these are in the base, but how to make these arrangements, arrange and sort rows. See, destination, fric destination, flights, this is the new object which is being created, and flights. So group by destination. See, first I would like to go into the, here we have done all these things, we have already studied, get a histogram of that, then arrange and sort rows, fric destination, this is the frequency of destination. See, flights, and then group by destination, and then again we are using the pipe and summarize number of flights n. So here this is the destination, ABQ, ACK, ALB, these are the destinations, and number of flights 254, 265, like that. Now we can arrange in terms of maximum or minimum, in increasing order or decreasing order. So for that we have to talk about arrange. Arrange function is for arranging the data in increasing order. So LEX have the minimum destination, LGA is the minimum, and then A and C, and maximum, it is minimum to maximum, it is increasing order. So arrange number of flights. First we have created number of flights by making fric destination, and number of flights is equal to n, and then we are having arrange fric destination, fric dest, and then we are arranging the number of flights. So, it is now arrange them in ascending order. So, it is arranging in the ascending order, and to arrange in descending order, fric dest arrange is already there, but here descent, so decreasing order. So, here it is arranging in the descending order number of flights. So, this is ORD is the maximum number of flights 17,283, then ATL it is the second largest number of flights. So, this way we can arrange them. Now, in my next talk, I shall talk about join data frames. So, that will be my next lecture.